So today our topic we're going to discuss is the clip model. For that, the paper name is okay, learning transferable visual models from natural language supervision. So before starting, I want to introduce you to online Google's Note LM. Okay, so what happens is that you can just download any paper and then just upload it here, and it will just summarize the whole paper, and you can even generate the quiz flashcards and slide desk or anything like from here. Okay, so it just gets so easier. You can even do on the chat gpt and all that, but it's specifically for the research purpose, so it's very good if you use it. So I have actually made these slides from this AI paper that we're going to study, the clip model, and they are actually very good. All right, so let's start. Okay, so what is clip? We'll start from what is clip: contrastive learning image pre-training. So getting in a background, हुआ गया कि NLP में there was a concept that when transformers came in, तो हम लोगों ने देखा कि transformers में we just pass a sentence and the sentence breaks into different tokens, and then through those tokens we can learn the relationship. Through the positional embeddings we can learn that how the words are interrelated to each other, right? So it's the attention mechanism and the positional embeddings and all that. You must have learned it. Okay, so that's how we learned how to actually predict or generate new text, right? So that was the breakthrough in the NLP area. So the when we thought about the NLP, after that we thought that what if we do the same in computer vision? How can we do that in computer vision, right? So here comes the clip. So clip is a multi-model learning architecture developed by OpenAPI, right? So what it does is that it learns the visual concepts from natural language supervision. So what does it mean? That it actually means that when we are talking, like, think about it, when we are just teaching someone, the if we teach through the visions, if we teach through the images, not just through the text, it would be like better understanding. All right, so only just through text or only through the images, right? The better one would be if we use the visual concepts and the language, natural language supervision. So what this clip we actually did the same things, kind of same thing, right? So what we did, that there was the we give the visual text, like for example an image of a cat, we passed it to the model, and then we actually passed the text with it. Like if the cat was sitting on a table, we passed the caption with the image that cat is sitting on the table, not just one label that we did in the CNN. Like in CNN, what we did, that we just passed one label like cat, and then we passed the image of the cat, and then the model learned that this is a cat, and on the classification it just predicted the label of the cat. What's the difference now here is that we just don't pass one label, but we pass the whole sentence. Like the cat is sitting on the mat, and when we pass the sentence into the model, all right, and with that model we just pass the image of the cat that is sitting on the table. All right, so this was the concept in the clip that we actually try to do. So what happened, that we needed a lot of data with the images and the text. All right, because a lot of data was needed. So what happened, that they actually did what, they collected the data from the internet. There were like 400 million data that had images and they trained an image encoder and then a text encoder with simple contrastive laws. Given the collection of images and text, predict which pair occurred in the test. Now what does it mean? We can discuss that. First, what is the image encoder, and then the text encoder, and then the simple contrastive laws. What we did, first the image data was collected, right, and then filtering happened and all that. Now what is the image encoder? Image encoder, you must have learned it in the transformers, that when we pass the sentence, we encoded it into the vector space, right? In the embeddings we did it with we did the embeddings of the text, right? So embeddings means, you can say, we converted the sentence into the numeric form, right? In a Latin space we call it. and there were positional embeddings of the text. Like that, for the image, what we did is we used, like, there were two types. We used either the ResNet encoder and then VIT encoder. What's ResNet? Let's discuss a little about it. The ResNet, the CNN, it's basically the CNN architecture where there are the convolutional layers like this, right? There are convolutional layers, and then the last is the classification layer, right? The feature vectors and all that. What difference is in the ResNet and CNN? The difference is that the in the convolutional layers, between the convolutional layers, we have a residual connection. We create a connection between, like this, right? So what we do is that we pass the data from here to the next feature maps to the next convolution layer, and then those feature maps new generated we pass it to the next model, if this was a CNN. But with the ResNet, we actually pass the starting the previous the generated to the next layers. All right, so what happens is that this model pass data to this one and this, and we just also pass the previous one, so it kind of don't want to miss the features, right? So if this is a very deep layer, what happens is when we pass through the layers, the feature maps, there will be noise and there will be problems that the feature maps maybe get distorted. So passing the previous feature map again could solve those problems, right? So this was the ResNet layer, the reason behind. And then we use the ResNet encoder as the architecture encoder. And then other one was the VIT encoders. Now what is a VIT encoder? VIT encoders, what does it do? That if, for example, we have an image, right? So in CNN we just pass the images directly, and then there's the feature map and all that, right? But in the VID encoders, we just pass, there's an image, all right, like this, and we don't just pass the whole image into the model. We actually does what that we divide it into like this patches. There's patch 1, patch 2, patch 3, patch 4, right? Like we when you can just actually relate it with the NLP, that where we pass a whole sentence, and then the sentence is broken down into the different tokens, and then the tokens are passed into the model, right? Like that, in the VIT encoder, what we do is we pass the image, and then we make patches of it, and then we pass the patches of the image into it for the and then we put the attention and all that. So what we do is that we get the better understanding of the image and the relationship between the different characteristics in those images too, right? So this is the VID encoder. These are the encoders that we used in the CLIP model. Now we get the first we get the encodings of the image. Now with that image, we also have passed, we talked about it, that we are going to pass the natural language thing, that is the sentences or the captions of the images, right? So what we did, that with that we passed the encodings of the sentence, right? So we'll say like this: Pepper the Aussie pup, right? This is the sentence, this is the image. So we pass it into the text encoders. Here it is the transformers, and you must have learned it in the transformers. It's already discussed in the previous I guess the lecture, but just for the overview, it's the same as VIT. Concept is same, that we pass a sentence and the sentence is broken down into the small tokens, and then there's a positional embedding, and we learn the relationship between the words, right? The pepper and the pup, and right, and the attention mechanism, like here in the VIT. And then when we do the encodings, this is the image encoding, these are the text encodings. Then what happens is that we get a matrix kind of, okay? So now we're going to learn what's contrastive pre-training. All right, so what happens is that when we do this and we get a matrix, now there is a matrix for image, there is text 1, for image 2 there is text 2, image 3 text 3. So all the actual pairs are in the diagonals, right? So there is labeling of image 1 and text 1, that's in the diagonal in this, right? The right pairs are in the diagonals, okay? So this image text is here, and image 2 has the text 2, image 3 has text 3. And not just the actual pairs, there is a relationship between other pairs, right? The image relationship with text 2 pair, image 2 caption, and then image 1 relationship with the caption 3, image 3 caption. Now why are we doing this? This is the contrastive pre-training. Why are we doing this? That we want to maximize this diagonal entries. Like there's going to be a similarity score. We are going to calculate a similarity score based on the cosine similarity, right? We're gonna actually make the model learn that which uh, text is related to the which image, right? So this text is related to this image and this one is this. So we just don't want it to learn that which caption is the best, which is the more linked to that image. We also want it to learn that which is not related to that image. All right, so this text, this one is not related to this one. So they can see his here it's minus 0.8 and the similarity score is 0.9. So it's going to be the maximum, the diagonal entry is going to the maximum, the actual caption of the image, but all the others are going to be the less similarity scores. So the model actually learns that which one is more related to the image and which one is not related to the image. So if we just teach a child that this one is good for you, okay, and with that we also teach the child that these things are not good for you, okay, so the understanding just becomes vast, right? So this is the contrastive learning, that we there is a positive samples and then there are negative samples, right? On not on the diagonal ones are the negative samples. So we want to maximize the ones on the diagonal ones, okay. So we what happens is that the model learns the similarities, not just the similarities, it actually learns the differences, right? So from the caption it actually learns that these are captions of the similar, that means these are the similarities, and the captions that are not linked or very close, those are their differences. So that's a better and more actually a good understanding, the contrastive learning, right? So yeah, so this is input image and the dog lying in the grass. It's going to learn that this is, we are going to minimize it, so it's going to learn that this is not, this would not be a dog, and here the dog lying on the grass is going to be positive one. So this is the clip architecture, the input X, and then there's the image, and then there's byte by wise encoding, transformer encoders with these layers, and then there's VIT that we just discussed, and then there are going to be some embeddings or projection, and then image feature representation, text feature representations, their resonant variants, and anyways. So we just learned that both into contrastive pair, and then we can use it. These are some formulas. Take the entropy loss and text to image loss, and these are, you can just look into it if you're interested in the math. Okay, we had all right now we're just getting into the concept of things. So after that we can do the clip inference. For inference, what we do is that this is the these are all the text, all the different options that we passed into the model, right? If we passed a photo of all plane, car, dog, and bird, we can just pass all these options to the model. The text is encoded, and then we just pass the image. All right, and we want the model to do the inference, and then what will the model do? That it will find the best matched caption in the image pair, the photo of the dog, and the maximum one will give the maximum similarity score. All right, and this is the zero shot linear classifier. We can also call it that we can without pre-training the whole data for a new kind of image, or we can just, and all the new kind of data, we don't have to train it from the scratch. We can just go into the give it the prompt of different all the images, and it will learn basically on the zero shot prompting. It will just make the differences, and it will build the similarity score. So yeah, so it, because of this, the zero shot prompting, zero shot learning, like see the accuracy it gave, right? So you can see the different. All right, and these are the key applications of clip: the zero shot image classification, the text to image retrieval, and there's a visual question answering. You can pass the image and you can just ask different questions. Zero shot image classification you can do, that we just did. This was the main idea of the clip model, right? Right, that's for now. Let's just look into some more concepts here.